Welcome back to another Mathvise video. In today's video, we'll be going over graphing polynomial functions, finding their end behavior, where they increase and decrease, and their extrema. So let's go ahead and get started. When graphing polynomial functions, you'll need to know how to graph them and analyze them for information. So let's go ahead and take a look at our first example. But before we look at that, we need to understand end behavior. End behavior is very important when it comes to graphing polynomial functions because it tells you the general shape of the polynomial. So this table shows you end behavior in relation towards the leading degree that you're given. So if you're given, let's say, x to the fourth, that is an even number. So we'll go ahead and look at this even right here. And since it's positive, we'll look at this positive right here. So that means our end behavior will be up, up. Basically, the end behavior indicates how the graph will look in terms of where you put the arrows. So like when you draw a linear equation, it looks like that. End behavior tells us that it's going to look up, up, like this, similar to a parabola. And if it's negated, like negative x to the fourth power, it'll be down, down. The same thing goes for odd powers, like x to the third power, similar to a cubic function, it'll look like this. And if it's negated, like negative x to the third power, it'll look like this. So just keep that in mind before you graph your polynomial functions. So let's go ahead and look at our first example. So how would we graph this polynomial function? Well, we need to find our leading power. When I mean leading power, I mean we need to look at the exponents of each of these parentheses. We have a 2, there's nothing here, which signifies a 1 and a 1. If we add those together, we get 4. Same to x to the fourth. And once again, keep that end behavior in mind. It's raised to a positive even power. So our end behavior will be up, up. So now we know the general shape of the polynomial function. We can go ahead and start graphing. So let's go ahead and graph our chart. So this is x-intercept form, basically saying that these are our points on the graph. So if we set these all equal to 0, that'll give us our point. So x minus 1 equal to 0, x will be 1. X plus 4 equal to 0, x will be negative 4. X plus 1 equal to 0, x will be negative 1. So that's how easy it is to just find the x-intercepts of a polynomial function. And now we need to go ahead and draw the general shape of the graph. Most teachers won't be picky with this as long as you have the end behavior, the x and y intercepts correct. So we'll go ahead and go through negative 4 because it is raised to an odd power, and when anything is raised to an odd power, it'll go straight through the point. And then we'll turn and go through negative 1, which is also raised to an odd power, so we'll go through it. Then we'll go to 1, which is raised to an even power, so it'll bounce. Whenever you're given an even power, just think of it as bouncing, so it'll bounce off this 2, this 1, and go to infinity. So that's how our polynomial function should look. Now keep in mind when you're graphing polynomial functions, you want to make sure your y-intercept is actually correct. So let's go ahead and find our y-intercept real quick. If we plug in 0 for x, that is how we find the y-intercept. Plug in 0 for x, we get negative 1 squared, which is 1, times 4, times 1, which is 4. So this point should be 4. So let's go ahead and analyze this polynomial function. We want to find the end behavior, the x-intercepts, and the y-intercepts. Our end behavior, as we discussed earlier, will be up, up. Our x-intercepts are these points given to us and the ones we just plotted, which is negative 4, 0, negative 1, 0, and 1, 0. And our y-intercept, as we found out by plugging in 0 for x, will be 0, 4. The last thing we want to look for is increasing and decreasing intervals. You may or may not be asked this on a test, but we'll go ahead and cover it for the sake of review. This part right here is decreasing. So I'll go ahead, just put that in red. This part right here is increasing. So I'll put that in white. This is also increasing as the slope is increasing, and this is decreasing. So that's the increasing and decreasing intervals for this polynomial function. And that is how you graph this polynomial function and analyze it. If you're finding this video helpful so far, take a minute to like this video and subscribe. And if you have any similar questions to this, you can join our Discord server linked first in the description down below, where you can ask your questions and get answers. Let's go ahead and take a look at our last example here. So similar to the last problem we did, let's find our leading exponent or leading degree. We have a 2 here and a 1 here, which is x to the third. The end behavior of x to the third is down up, or the end behavior of a positive odd exponent is down up. So just keep that in mind. So now we can go ahead and plot this. So let's go ahead and draw a graph. So go ahead and plot our x-intercepts. Set this equal to 0, we get -2. And set this equal to 0, and we get 1. So this is a little bit easier than the last example because we only have 2 x-intercepts instead of 3. Again, our end behavior is going to be down up, so let's go ahead and draw those arrows so that we can quickly and efficiently graph this polynomial function, especially if you're given something like this on an exam, you want to be quick. Then we're going to bounce through -2 because this is raised to a even exponent. And then we want to go straight through -1. So let me go ahead and redraw this. So bounce at -2 and go through -1. Once again, we want to make sure that this is the correct y-intercept. So we'll go ahead and plug in 0 for x. We'll get 0 plus 2 squared, which is 4, times 0 minus 1, which is -1. We'll get -4. So this right here is -4. So what is our end behavior, and what are our x and y intercepts? As we discussed earlier, our end behavior, as indicated by these arrows, will be down up because we have a positive odd exponent. Our x-intercepts were given to us as -2, 0 and 1, 0. And our y-intercept, which we found by plugging in 0 for x, is 0, -4. Let's go ahead and find the increasing and decreasing intervals for this graph. I'll use increasing as white and decreasing for red. So right here, this graph is increasing and decreasing, and then increasing once again. So that is how you graph this polynomial function and analyze it for its end behavior, intercepts, and increasing and decreasing intervals.